This lecture video is about solving absolute value equations. Before we get started on solving some, though, we need to look at the definition of the absolute value. So the definition of the absolute value is that the absolute value of x is equal to x. So it's just whatever's inside the absolute value bars, as long as x is greater than or equal to 0. If what's inside the absolute value bars x is negative, or less than 0, then you have to change its sign. So really this is the distance that x is from 0. So if x is positive, then you just remove the absolute value bars. If x is something that's negative, then you have to change its sign. And the way that we do that or denote that in math is we multiply by -1. So if x is less than 0, then what's inside the absolute value is negative x. So what does this mean when we're solving an absolute value equation? Well, if the absolute value of x is equal to 6, then there are two values that would give us that. Either x has to be equal to 6, or x can be equal to -6. Both of these will give you a true statement when you plug them in for x. Okay, so let's take a look at another example. And I don't know why this didn't change, but that should be example B. The absolute value of x is equal to -6. Well, again, remember the absolute value is a distance, and distances always need to be positive. So when you're solving these, if you see an absolute value is equal to a negative number, that's impossible. And so this means that there's no solution. So just make sure that if you run into this situation, you say that there's no solution for that. On our next example here, the absolute value of x plus 4 is equal to 9. So there are two ways that x plus 4, the absolute value of that could give you 9. That's if x plus 4 was actually equal to 9. That would give you the absolute value is equal to 9. Or if x plus 4 was equal to -9, then the absolute value of that would also give you 9. So there are going to be two solutions here. And when you're solving absolute values, you'll always have these two solutions. You'll always have just drop the absolute value bars out, and that gives you this first equation. And then drop the absolute value bars, but change the sign over here on the right-hand side. So to solve these two, we're going to subtract 4 from both sides of this. And the first one gives us x is equal to 5. Subtract 4 from both sides of the other equation, and we get x is equal to -13. So both of these, x equals 5 and x equals -13, will give us a true statement. In our next example, the absolute value of x over 3 minus 2 is equal to 1. So again, we write out our two equations. The first one is just this equation without absolute value bars. So x over 3 minus 2 equals 1. The other equation is just dropping the absolute value bars from the left-hand side. So x over 3 minus 2. And this time, instead of 1, we're going to have -1. So now we need to solve both of these equations. I'm going to add 2 to both sides. And we get x over 3 is equal to 3. And then to get that 3 out of the denominator, we're going to multiply by 3 on both sides, so we get x is equal to 9. In the next one, solve it the same way. We're going to add 2 to both sides of the equation. That gives us x over 3 is equal to 1. And then to get rid of the 3 in the denominator, we multiply both sides by 3, and that gives us x is equal to 3. In our next equation here, before you can write out your two equations, you need to make sure that your absolute value is by itself first, and right now it's not. We have 6 times the absolute value of x minus 7. So first we need to get this absolute value alone. So we're going to add 7 to both sides. That gives us 6 times the absolute value of x is equal to 12. And then we have to divide by 6 to get that absolute value alone. We get the absolute value of x is equal to 2. And that gives us x equals 2 and x equals -2. Okay. This one we already have the absolute value alone. This is sort of a unique situation. When you have an absolute value equals 0, then there is only one situation because there is no positive or negative 0, it's just 0. So this is just 5x equals 0. And when you divide both sides of this by 5, you get x equals 0. In this next example, absolute value of 2n plus 3, and then outside of the absolute value of plus 9 equals 4. So again, before you can set up your two equations, you need the absolute value alone. So we're going to subtract this 9 from both sides, and we get the absolute value of 2n plus 3 equals -5. And remember, absolute values can't be negative, so this is no solution. In our next example, again, we have to get this absolute value alone. We have 2 times the absolute value of x minus 1, and then outside the absolute value plus 15, and it equals 20. So we're going to get this absolute value alone first, so we're going to subtract 15 from both sides. We get 2 times the absolute value of x minus 1 equals 5, and then we have to divide both sides by 2. So I have x minus 1 equals 5 halves, and the other equation is x minus 1 equals -5 halves. So now we're going to add 1 to both sides. And 1, remember, is 2 halves, so this would be x equals 7 halves. And again, add 1 to both sides of this. And again, 1 is the same as 2 halves, and -5 halves plus 2 halves gives us -3 halves. And you can check your solutions by plugging them back up into the original if you want. And we have 2 more. These ones are unique because they have absolute values on both sides of the equation. So the question here is, does this mean that we have more than just the 2 equations, or will we have more than that? Well, let's take a look at this. So one possibility is that we would have 5x plus 9 equals x plus 4. That's just dropping out our absolute value bars. Another option would be keep the left-hand side the same again. 5x plus 9 equals -1 times x plus 4. So that's multiplying the right side by -1. One other possibility that we could think about is this time leaving the right-hand side the same, but multiplying the left-hand side by -1. And I'm just going to move this. We'll actually just put it down there. And one other possibility, so here we left both sides the same. Here we multiplied the right side by -1. This time we multiplied the left side by -1. The last option would be multiplying both sides by -1. So now the question is, are all 4 of these different? And the answer is no, they're not different. These two are equivalent to each other. If I just multiply both sides of this by -1, oops, let's write that a different way. So -1 times this side and multiply this side by -1, then you will have this quantity times -1, and this will become positive, so it'll be exactly that. So these two are a repeat of one another, so we only need one of them. What about this situation? So here, again, if I multiply both sides of this by -1, oops, pen's doing funny stuff, but this side then will become positive, and so would this side, and so we have exactly this same equation. So these two are repeats of one another, so we only need one of those. So even when there are two absolute values, one on each side of the equation, we still only have the two equations that we had from before. One is just to drop out your absolute value bars. The other one is to drop out the absolute value bars but multiply the right-hand side by -1. Just make sure that if there's a bunch of stuff in here like this x plus 4, that you put that in parentheses. So let's go ahead and solve these. So we want to get all the constants on the right and the x terms on the left. So we're going to subtract 9 from both sides. So we have 5x equals x minus 5. And now we're going to subtract x from both sides. 5x minus x is 4x, and it's equal to -5, and then divide by 4. So we have x equals -5/4 is one solution. Here I need to distribute this negative sign first. That gives me 5x plus 9 equals -x minus 4. And do the same thing as we did before. Subtract the 9 from both sides. We get 5x equals -x minus 13. Now because this is -x, we have to add x to both sides. We get 6x equals -13, and then divide both sides by 6. And that gives us x equals -13/6. And then our last one, absolute value of 1/2 x plus 3 equals the absolute value of 2/3 x minus 1. So again, our first equation is just dropping out those absolute value bars. 1/2 x plus 3 equals 2/3 x minus 1. And the second equation is going to be dropping out the absolute value bars. But we're going to multiply the right-hand side by -1 and make sure that you put that right-hand side in parentheses. So now we're going to solve these. Subtract 3 from both sides. We get 1/2 x is equal to 2/3 x minus 4. And I like to get rid of my fractions, so I'm going to multiply by the common denominator of 1/2 and 2/3. So that's going to be a 6. Just remember that you have to multiply this 6 to all three of these terms. And 1/2 times 6 is 3, so that gives me 3x. And then 2/3 times 6, so 6 goes in, or 3 goes into 6 twice, so that would be 4x. And then don't forget to multiply this 4 by 6 as well, so that would be -24. Now we subtract 4x from both sides, giving us -x equals -24, and then divide both sides by -1. And we get x is equal to +24. Here we have to distribute the negative sign first. That gives me 1/2 x plus 3 equals -2/3 x plus 1. And now I'm going to subtract my 3 from both sides. I get 1/2 x equals -2/3 x minus 2. And again, multiply everything by 6 to get rid of our fractions. 1/2 times 6 is 3, so that gives me 3x. And 2/3 times 6 is 4, so that's -4x. And -2 times 6 is -12. Now I want to add 4x to both sides. We get 7x equals -12, and then divide both sides by 7. And we get x is equal to -12/7. And that finishes up our lecture on solving absolute value equations. Let me know if you have any questions. Thank you.